Okay, good evening everyone. Welcome to the second talk. So today we have Andrew talking about cool stuff in the night sky, and so hopefully this will be particularly useful for the astronomy evenings we run next term. As I was at the last one, I enjoyed it. Hopefully there'll be some more happening. Okay, over to you.
Okay. But yeah, I just want to give kind of a simple, easy, nice, relaxed overview of the cool things that you can see in the night sky. So to reflect the casual nature of this talk, you see the title, just seeing cool stuff in the sky. Nothing too rigorous here. So here's the overall plan for the talk. It should go for about 20 minutes. I'm going to first talk about stuff you can see with your unaided eye, satellites and shooting stars or meteors. Then I'll talk about some easy things you can see through a telescope if you've got one. Okay, so I'll get started with satellites. This is a pretty awesome satellite to see, the International Space Station. You can see it's got all these massive solar panels here, and they're pretty shiny, so you can usually see it pretty well when it's passing overhead. It's got a typical magnitude of about -3. So,
What do you mean by magnitude?
what do I mean by magnitudes? That's a good question. Magnitudes are an astronomer's unit for brightness. So the smaller the magnitude number, the brighter the object. So it's also a logarithmic scale. So a change of 5 magnitudes to EBIT corresponds to a factor of 100 change. Yeah. So if something's 5 magnitudes brighter, it's actually 100 times physically brighter in terms of flux. So the International Space Station can be a maximum of about -6. Typical stars, typical bright stars are about -1 to 0-ish. So the more negative the number, the brighter they get. But usually you can see the space station at about -3. Just out of curiosity, have any of you actually gone out and had a look at the space station? Do a show of hands. Oh, quite a few of you. Yeah, that's good. And so, well, as you would test.
It was cloudy. It's rough, Jake.
So this is the proof that we can actually see it here. The space station can see us down here in New Zealand. We can probably see it sometimes as well. Good line of sight there. But there's another kind of satellite that's very awesome to see. They're called Iridium communication satellites, and they make events called Iridium flares. So you can see they're pretty shiny. They've got all this metal and solar panels, and they rotate and they orbit the Earth, and so you can calculate the exact time and the exact brightness that these satellites are going to appear if you use computer programs. So these ones can get ridiculously bright. They can get a maximum of -9.5. So that's probably like looking at the lights of a plane heading straight towards you for a second. So they're pretty ridiculous. I've seen magnitude -7 Iridium flares, and they were pretty overwhelming. I've never seen a -9 before, but apparently they're possible.
Just out of,
yes.
sorry, out of interest, do you know what the magnitude is of like the moon? You know, full moon or something like that? Or the sun?
The sun?
Yeah, the sun's pretty big.
Yeah.
Can't remember what the moon is.
I think from memory it's about -10 or -13 or something like that.
Yeah.
So these things are comparable to the brightness of the full moon, but the thing is they're just a point in the sky.
Yeah.
So they look pretty spectacular.
That's pretty awesome.
Yeah.
I actually saw one once without knowing what it was. It blew my mind. I was trying to especially research at the time about my knowledge of the sky.
Yeah.
I was quickly put to shame.
It's all good. All good things to see. So these are some ways you can identify when there's going to be bright satellites like the space station or Iridium flares. So you've got a website called heavensabove.com. So you input your location on the Earth, and then it will calculate visible passes for the space station and Iridium flares, tell you their magnitudes, and give you some nice star charts to show you where they're going to be visible in the sky. But probably more convenient than that, there's actually cell phone apps you can get. For Android, there's SatTrack, and then for iPhones, which I haven't actually used, but I put it there for completeness, not being an iPhone person, is GoSatWatch, which I guess is pretty much the same as SatTrack. But SatTrack and Heavens Above I've certainly had a lot of experience with. And they give you results like this. So this big star chart on the left is what Heavens Above tells you. So star charts are always pretty confusing to read, to be honest, but the best thing I find to use them is you can look up, you can see that this one will pass pretty close to the constellation of Scorpius, and that's a pretty easy to identify one in the sky. So if you look up in that part of the sky and wait a while, maybe a couple of minutes when this thing's supposed to be passing by, you should be able to see it. And then SatTrack actually gives you a nice compass and points you in the exact direction, a nice countdown. It's all pretty easy really. Just a pro tip, if you do use SatTrack, when it's daylight saving time, you have to set the time zone manually to plus 13 hours. It doesn't account for that. Otherwise you get out by an hour, which isn't fun. You end up staring at blank sky.
How long did that take you before you
Actually, just one night. Just one night.
Just the whole night, or?
It took a while. But if you're ever in doubt, just go to the Heavens Above website, because these apps actually just use the databases on that website anyway. So that's basically all there is to seeing satellites in the sky. So now I'll talk a bit about meteor showers. There's really only two things you need to know to see a meteor shower, or some meteors from a meteor shower. There's when the peak of the meteor shower is, and the approximate direction to look in. So meteor showers all radiate from a central point called the radiant point. So that's actually shown nicely in this picture here. You can see them all radiating away from that radiant point. Because meteor showers are annual events as well, you get them at the same time each year. You don't actually need to have like a cell phone notifying you when it's going to be like a satellite passing over. All you really need to know is a calendar. And so on the Royal Astronomical Society of New Zealand's website, they've just got these tables of visible meteor showers from New Zealand. And you can see actually, maybe you can't, it might be a little too small to see, but we are in, actually kind of in the tail of the meteor shower distributions for a few of these ones. But this is the peak rate per hour, so the ones that we've got currently are pretty pathetic. It's about 2 to 3 per hour. But in the future, in kind of, when is it, November, there's the Leonards, that's predicted to be about 100 plus per hour. So it'll be worth having a look at if we get clear weather. Any questions about spotting meteor showers?
Why are they happening?
What was that?
Why do they occur at the same time every year?
Oh, it's because of the way the Earth orbits around the Sun. When it's ploughing through a big, I guess, basically a cloud of dust, from what I understand.
They're often left over from comets.
Yeah, I think so. So as comets leave debris as they come in towards the Sun, the Earth ploughs through this debris field at the same time each year, because it's in the same place in space in its orbit. Yeah. I guess I'll move on. There's nothing too much to meteor showers. But this is often the case when you're trying to find things with a telescope. They all look alike to me. Anyone of you actually tried to find things through telescopes? How many of you have got telescopes? Yeah, quite a few. Good turnout, yeah. So You probably all had that experience of trying to find a planet or a star cluster or a nebula and only seeing black or just random little stars that don't look too impressive. So there is definitely some tricks to know to being able to find these sorts of things. I'll talk a bit about some easy objects to see. Yeah, that's an important disclaimer. A very important disclaimer. A lot of people look through telescopes expecting to see something like this taken by the Hubble Space Telescope. If you look through a normal telescope at the Orion Nebula, you probably just see kind of a cloudy, hazy region. You can definitely see there's something there, something like a nice cloud with some interesting structures, but you don't get any of that nice colour unless you do a long exposure photograph through a decent telescope. So some easy objects to see around this time of year is Jupiter, in the summer, right out there. So these are nice objects to see in the summer, Jupiter and the Great Orion Nebula. So these two are both pretty much in the north of the sky in the Orion constellation, which is what's shown here. This is a pretty accurate picture showing what you would see if you looked up just with your naked eye. It's this group of stars up in here. So I just zoomed in on that. There's this group of stars. Now one of those is that nebula I just showed before. Trying to find which one, if you didn't know, would be a bit of a can't really tell just from looking. So there's some useful apps to help you find these objects. We've got for Android the Google SkEye map, and we've also got SkEye, I guess you pronounce it SkEye maybe. Not sure, but they're both pretty useful. You can type in the object you want to look at and it'll direct you to it in the sky. And then I believe one that's useful for iPhones and iPads is SkySafari, though I've never actually used it myself. I'm an Android man. There's also one more very useful program you can use. It's not a cell phone app. Stellarium. Wheels was saying you've used this before.
Yeah, a little bit.
Anyone else used Stellarium before? Yep. So it's a pretty nice little program. Hopefully it's all free, and it simulates what the night sky would look like if you were out there. So here's Stellarium running. It's showing a satellite passing over there. This is actually set for about 8:15 tonight. So currently we're pointing south. But what I'll do is move it to the summertime, and I'll show you how to find the Orion Nebula. January. Okay. So you want to point north. So this is this group of stars here. That's what I was showing on that picture before. Those three stars in a line there is the iconic belt of Orion. And you can just maybe see, just where my mouse pointer is, there's three faint stars there in a row. It's called the Sword of Orion, but actually that one in the middle is that nebula. So if we zoom in on that, just to prove I'm not lying, there it is. And then if you wanted to find Jupiter as well, I'll zoom out a bit so we can see the whole, so there's the horizon. You've got a whole lot of bright things up here. There's Sirius, that's the brightest star in the sky, Betelgeuse and Procyon, and then the lowest bright thing towards the north will be Jupiter. This is for the summertime though, we can't see the stuff at the moment. And you can usually see up to 4 of those Gallian moons through a reasonable telescope when you look at Jupiter. So that's the summertime stuff. But now, what I'll do is show you some easy to find winter objects that we can see in the sky now. So we've got Saturn. That's a pretty impressive thing to look at through a modest telescope, maybe about this kind of size. You can make out the rings of Saturn. And then the star cluster here, a nice star cluster called the butterfly cluster, obviously because it looks like a butterfly. It's pretty clear, I think. The butterfly cluster, also called M6. So let's come back to Stellarium again and have a look for those. So we're back to the current time now. It's still a bit light outside, so I'll just advance the time a couple of hours. Here we go, so about 20 past 7. So we're pointing kind of north to northwest. You can see there's Venus in the western horizon setting, the moon there. And there's some three bright things in this part of the sky. Hopefully you'll be able to see them if you just looked in that direction. These two are pretty obvious to see. That's the star Speaker, and it's in a line with Saturn, and it's the one on the right that's Saturn. You can't really tell just by looking with your naked eye, but if you point a telescope at that star that's on the right there, as we'll pretend we're doing now, and zoom in, there you go, it's Saturn. So that's one trick for spotting Saturn, just look for a speaker. Because it's a planet, it does move relative to the stars, but because it's so far away, it doesn't move much. Because it's got such a slow orbit around the sun. And then the butterfly cluster, we want to look towards Scorpio. Hold on, I'll cheat here. Just get it pointing towards Scorpio. Alright, here we go. So this is Scorpio up here. I can turn the lines on. It's pretty easy to spot. Not Scorpius, sorry. Get the name wrong. Easy to spot with that Antares star. It's a red giant, so it's nice and easy to see. The best way to find the butterfly cluster is kind of to draw a line between this star here and Scorpius' tail, and come down to this one, and then come approximately the same distance down, and then go a little bit towards this star, and somewhere around here. What you would do if you had a telescope would be to point it up in approximately this part of the sky, and you would see it through your finder scope as a kind of a hazy little group of stars. So I think it's kind of about... Is that it? There's quite a few star clusters up in this part of the sky actually, so if you do go wrong, you'll probably still see something nice. A little more to the right.
That cluster just right
That
there.
one? It's M7. It's definitely a star cluster.
Just cheat again.
Yeah, cheat again.
We were close. You have fun and games trying to find these things. But you can actually just make this thing out with the naked eye, so it's not too bad to find. Once you identify where Scorpius is, which isn't too bad, it's one of the more noticeable constellations. So now I've just got one more category to show you. The stuff we can see, a couple of objects we can see all year round. So there's the jewel box cluster, aptly named I think because it looks a little bit like a box of jewels. There's an orange-red star there which looks like a ruby or something, along with some sparkly blue stars. Then we've also got Omega Centauri, which is a globular cluster. Omega Centauri is just visible to the naked eye if you don't have a bright moon. But both of these are visible all year round from New Zealand because they're circumpolar. So let's play finding them again. So we want to look approximately south. I'll turn off all these constellations. We'll go for the jewel box first. We want to look for the Southern Cross, which is this constellation here. It looks a little bit better on my screen, but can you all see it?
Yeah.
Yeah, okay, that's good. So you want to look around this star of the Southern Cross that's closest to the pointer stars, and just above it is the jewel box. So basically point your telescope at this star here, and then hopefully the jewel box will be somewhere in your finder scope, and then you can just line it up on that. I'm going to zoom mine in. It doesn't look as nice here, but that's the cluster. I guess it'd be a bit much to ask them to render every cluster that it circulates to Hubble Space Telescope detail. And Omega Centauri is again in this part of the sky. The trick to finding it is you draw a line between Beta Centauri, that's the fainter of the two pointer stars, closest to the Southern Cross. You draw a line between that one and a nearby bright star, Epsilon Centauri, if you're keen on the name. It's in a straight line, so just look for a fairly bright star above the Southern Cross at this time of year. And then you go the same distance out across again from those, and somewhere in that, there it is, Omega Centauri. You can just see that little dot there with your unaided eye. Zoom in on it, and you see we've got a nice star cluster there. Not too flash, to be honest, is it? The picture looked better. But that's where it is. So, that's actually about all I had planned to talk about, but I'm happy to take questions or perhaps point out a few more objects if you're keen. Any questions or comments?
Just the Stellarium program. I've tried to find the Eta Carina Nebula a few times, and I can never find the bloody thing. So, can you show us where it is?
Let's see. Maybe not. Have you tried searching for it?
I think it's Carina.
Carina, yeah. If I spelled it right. Anyone know its catalogue index?
You had it there when you had Eta CAR, I think.
Right. Well,
Don't.
Eta.
Yeah, there we go.
It's like that.
Oh, okay. Whenever I got the scope out, I'm just like, where the hell is it free?
Yeah, so I haven't found this one for a while.
There's a nebula and it looks pretty
You do it.
It's kind of just look in between like the Southern Cross and the False Cross.
Oh, yeah.
It's sort of halfway in between the two.
Maybe if you join the tip or the tail.
Yeah, that would probably work.
Yeah. Sweet. I'll find this
That's
one.
right.
Any other objects you want me to look up while I'm here? 47 Tucanae is another nice globular cluster. It's pretty easy to find. So the way you find that is you just look for the small Magellanic Cloud, and then pretty close to that you can usually see with your naked eye, if it's a dark enough night, a little faint little dot. That's rendered. It is a free program in their defence.
They have to get paid. Like,
What was that, sorry?
it costs so much in bandwidth to transfer that much data.
Yeah. So, there's another globular cluster you can...
Can you just see the Magellanic clouds?
Yeah. Yep. Even on a... Well, it's certainly easier to see on a dark, moonless night, but even when you've got a full moon, you can just make them out if you know where to look.
What do they look like? Are they nothing much? Are they just
They actually look like
Yeah,
clouds.
this is pretty much how they look, I guess. They're just kind of a... They look pretty much identical to clouds at night, actually.
Yeah, it's real hard if it's like,
Yeah.
there's a few clouds in the sky, you're like, is it stars or...
Yeah.
The Tarantula Nebula is in one of them, isn't it?
Yeah, that's right.
pretty
The
sweet.
tarantula's in the large Magellanic Cloud. Around the edge somewhere. Might be. That might be it.
Tarantula.
Oh, yeah. Oh, yeah, so that was it. DC2070. That one's findable as well. You just basically point your telescope at the edge of the Large Magellanic Cloud, and then hopefully you'll see a slightly brighter part of that cloud than all the other parts of the cloud through your finder scope. And you just line the telescope up on that slightly brighter part. That's a nice one. That's a phenomenal object actually. It's on a colossal scale. It's something like 100,000 light years across this giant cloud of gas. Yeah.
I think I read somewhere that if it was the same distance as the Orion Nebula away, it would actually like light up the night sky.
Yeah,
It'd be like as bright as the moon or something. I'm not too sure.
Yeah, it's amazing.
Any other questions? Or?
Any interesting features on the moon's surface you can see with the telescope?
Yeah, plenty. I don't know the moon craters by name too well, but I know that when you're observing the moon, it's best to do it when it's not actually full. So when you can see that line of shadow, and then you can also see the shadows cast by the sun. Yeah, that's right. Because when you're in a full moon, the sun's basically from behind you shining straight down on the moon, so it doesn't cast any shadows. Shadows are quite useful to be able to spot those mountains and craters.
What exactly is the supermoon? It's not any closer, right?
Yeah, it is.
Or it is?
Yeah. It's not closer by much, but it's slightly closer. Therefore it appears
And that's
slightly.
what makes it bigger? Or
Yeah. But it's only, I can't really, it's a small amount. It's not noticeable unless you knew it was going to happen. It's not as noticeable as the apparent optical illusion of the moon appearing big when it's near the horizon.
And lensing effect?
It's actually just a pure optical illusion. It's the human mind.
Because you're comparing it, you've got a comparison scale.
There's a lot of very complicated answers to that particular question. But
I've actually heard that
there's no one really sealed upon.
I've heard that if you look between your legs, for some reason it mucks up the optical illusion and it no longer looks big.
Sorry, like you're standing bent over.
It could just be just a trick.
Two moons.
But the brain does lots of things when things are upright, and then when you like invert them, it just goes haywire. You just can't handle this stuff, and all its little tricks it plays, and you start falling apart.
Yeah.
I can believe that, but I also would do it. I could I hope Ethan would do it.
I totally would.
Exactly.
I'm planning. Who's next one, mate?
It doesn't work if you lift your legs above your head, though.
Well, thank you for the talk. Next week we have a talk that Hadley Frost is giving on sort of the information, so the entropy and thermodynamics of black holes. Now I've twisted his arm behind his back so he will not make it complicated. So I think that should be really exciting.